do you have any question to ask Dr. Arvind Ranade regarding what happened today, regarding the India's mission to Mars, the Mars orbiter mission?
So there are there are some detectors that has been installed in the Mars orbiter missions.
Okay.
One is the methane sensor. One is the mission sensor.
Yeah.
So can you explain? If it will be nice if Dr. Roy can explain the method that how it will demonstrate that there will be a sign of life if we detect the methane.
All right. Dr. Ranade, did you get that question?
Yeah, I have heard Mr. Palash, and let me explain in following way.
Yeah.
Yes, certainly this Mangalyaan has about 5 different payloads placed into it.
Right.
And no doubt within the next few months, we are going to get a lot of data from those sensors. But as long as he has asked for the MSM, that is methane sensor Mars. See, basically this particular Mangalyaan is going to be an orbiter, which will be orbiting around the Mars at the distance of about 400 kilometers at perigee and then 80,000 at apogee.
Okay.
Now, what is there? We actually were expecting to find out the concentration of methane, that too in the upper atmosphere of the Mars. So, in fact, if we are expecting that, that will certainly lead down to give the exact amount of methane which is sitting inside, then it will be a little exaggeration. However, this MSM is going to help us, because ultimately, what are the ways to understand this presence of a methane? Is nothing but because these instruments are sitting, I mean, at least one can consider at the distance of about 400 kilometers from the surface of Mars. And what is possible by these instruments is nothing but to just keep on taking the photograph in camera manner, or with the spectrograms or the photometer is nothing but the, because methane, we know methane is CH4, and which has the particular wavelength lines if the presence is available. So what we are actually trying to do is nothing but to keep on taking the photographs. I mean, in one way of say fashionably photograph, but nonetheless it's a kind of a data that we will be keep on gathering, and it will be not that easy to say that within the first few days that what is this the percentage of, but nothing but the depending on the properties of the CH4, and then at what level, okay, what the abundance, at what level it is to be there, will certainly be come out only after a certain pre-processing of the data, as well as the analysis of the data will happen. But nothing but it is, what we are going to do is to take the footprints, or rather fingerprints of the CH4 available inside the, inside, or rather one can say in the upper atmosphere of the Mars. And that will help us to tell, at least in some numerical way, that this is what could be the percentage. And I hope you, I mean, everybody knows that the presence of methane leads down to the exercise of finding out the existence of life in that particular object.
Right. Do you have any question for Dr. Ranade regarding the Mars mission, regarding the MOM?
Yeah, just a small thing which I would like to know. What's the difference between the US MAVEN and India MOM? Just what's the basic difference? So
yeah, that is the question even I had in my mind, Dr. Ranade.
Okay, good question. See, I mean, number one, I think in your this particular show that you were just did that you mentioned, it also talked about the MOVENs in comparison to the money and this fuel thing, which is there.
Right.
No doubt, money is certainly on the higher scale. I think what is more important to understand in this scenario is the accuracy, the efficiency, and then the instruments which are sitting on the MOVEN. Because no doubt MOVEN is technologically very advanced mission as compared to Mangalyaan.
Atlas 5 is more advanced than a PSLV? That's what you're saying?
No. PSLV is a launching vehicle. I'm talking about the payloads. I'm talking about the instrument sitting on the MOVEN.
Okay.
And then the objective that MOVEN is looking for, and the objective that Mangalyaan is looking for.
Okay.
Because I think it will be very easy to first understand, because our Mangalyaan is going to be parked in the orbit of say 400 perigee and about 80,000 apogee. But this Marvin is going to be about 150 kilometers at the perigee and about a 6,500 approach. That means it is very clear that this Marvin is going to have the high resolved kind of an observations as compared to the Mangalyaan. And then again, the objective that Morgan is looking for is to basically trying to analyze the impact of solar wind onto the Martian atmosphere. And as of today, I mean, the kind of instruments that we are dealing with are certainly not going to have that particular objective in the mind. And certainly because then again we are in fact the Morgan is also trying to look for the various other objects as well. So the kind of instruments that which are sitting on the Marvin are certainly very high resolved with the high efficiency, and of course a lot of one can say the expectations are going to be very high, and the major cost of it has also gone into the manufacturing of all those instruments, of course, as compared to the Mangalyaan. But nonetheless, what is more important again, we have to understand that we are able to achieve the same kind of an target with the less amount of fuel. And again, if you look at the trajectories that has been used by Indian Mangalyaan as your animation by the team member that has been flashed, also talks about how incremental the orbit was being used in our case. But in their case, there was not incremental orbit happened in Marvin. Only one at the perigee they have just gave a right amount of thrust, and it also requires a tremendous amount of fuel in sitting inside, and that Marvin had that capacity.
Right.
Like 90,000 Newton thrust, while ours was just about a 450 Newton thrust that we have been going with the liquid approach motor.